Hi everyone, we are from Group 1. Today we are going to present about assessment regarding Simplex method. This is our group members. First me, Dinesh Ravi, my matrix number is 207361.
My name is Muhammad Muaz bin Muhammad Nur, matrix number 206542.
And my name is Ahmad Dina bin Ismail, and my matric number is 208078.
The problem given to us is minimize when z equal to 2x1 plus 3x2. So this equation is the objective of our problem and is subjected to where x1 plus x2 more or equal to 40. Equation 2, 2x1 plus 3x2 more or equal to 90, and x1 and x2 must be more or equal to 0. These three equations are constant of our problem. First step, to solve a minimization problem in simplex method, first we have to change the minimization problem to maximization problem. To do that, we're going to use a matrix transfer method. First, we need to arrange the three equation which is objective and two constraint in a matrix form, and arrange where the row one column 1 is x2, column 2 is x2, and third column is a constant of the equations. From there we perform the transpose and rearrange the number according to the formulas. Then we can set a new uh, formula equation which is a maximization problem, which is p equal to 4y1 plus 9y2 subjected to y1 plus 2y2 less equal to 2, and y1 plus 3y2 less equal to 3, and y1 and y2 must be less or equal to 0. As you can see here, after we convert the maximization problem into minimization problem, all the constraints are become less or equal to. Before this, the equations are more equal to. This is a must, is a critical step that we need to follow. From here, next step, my team member will explain.
Okay, so from previous part, we have objective function and subject to constraint, which is two equation. So so we convert the inequalities form to equal, and then we move and then we add slack variable, which is s1 and s2 to both equation. Next. Okay, next. Okay. After that, we transfer all the equations into initial simplex tabular, uh, which is the yellow equation and blue equation. Um, we divide the most right number with the most left number, and then we found out that yellow equation have a lower value compared to blue equation, and then we set the yellow equation as the row one. So after that we perform pivoting to yellow equation because it has lower value. So pivoting is a process in order to obtain one value in the location of the pivot element, and then making all other entries 0 in the columns. So in order to make the yellow equation pivoting, so we have to multiply all the value of yellow equation with 1/2. So and then you got the value as in the simplex tableau. Okay, so next I pass to Daniel.
Okay, next slide, please. Thank you, Muaz. Okay, so after we get the pivot element, which is 1, in the first row and second column, we need to perform the elementary row operations to all the entries, number of each columns, in order to get the 0 values. So for the row 2 and second column, we can eliminate the number 3 by the equation R2 new equal to 3R1 minus R2, and we will get the 0 values. Next, we also need to eliminate the -9 which located at the row 3 and column 2 using the equation R3 new equal to R3 plus 9R1, which will give the zero values. After that, we will get the answers for the question, which is x1 equal to 9 over 2, followed by x2 equal to 0 and z equal to 9. And last but not least, we also can check whether the z value that we got is correct or not by using the x1 and x2 values that we get and substitute them back in the objective functions equations, which is z equal to 2x1 and plus 3x2. So I think that's all from our group. Thank you.